You know how sometimes you hear about something that sounds, well, almost like science fiction, but they could actually, like, change everything. That's kind of the vibe I'm getting around China's latest announcement.
You mean the Tsinghua reactor, the spark?
Exactly. The world's first fusion-fission hybrid reactor. And they're saying, what, up and running by 2030?
Yeah, it's incredibly ambitious. It's not just small thubs we're talking about here.
No, it feels like a potential leap, doesn't it?
Yeah.
Whole new way of looking at energy.
Absolutely. And what's striking, based on what we're seeing from places like Sustainability Times and other outlets, is how serious China seems to be about making this happen.
Right. It feels like a potential shortcut to a different kind of energy future.
It really could be. And for anyone listening, this is, well, it's the chance to get your head around a technology that might be shaping our world sooner than we think.
Okay, so that's exactly why we're doing this deep dive today. We want to unpack what this Tsinghua reactor actually is, why it's causing such a stir, and, you know, what it might mean down the road.
Good plan.
So let's start right there. What exactly is this spark?
Okay, so in simple terms, it's a reactor design that merges two fundamental nuclear processes: fusion and fission.
Right. Fusion and fission. Most people have heard of them, but maybe a quick refresher.
Sure. Fusion, that's smashing light atoms together like hydrogen isotopes. It releases enormous energy. It's what powers stars, basically.
Like the sun. Got it.
And fission is the opposite, splitting heavy atoms, like uranium. That's how our current nuclear power plants work.
Okay.
Tsinghua aims to use both together in one system.
Kind of best of both worlds idea. And the thing that's really grabbing headlines is this energy gain factor target, the Q value. They're saying above 30.
Yes, and that number, Q over 30, is why people are really paying attention.
Okay, for those of us not deep in nuclear physics, why is 30 such a huge number? What's the context here?
Well, think of Q as like energy efficiency. How much energy do you get out compared to what you need to put in just to make the reaction happen?
Okay, input versus output. Exactly. And aiming for a Q over 30 is, well, it's massive. Let's compare. ITER, the big international fusion project.
Yeah.
Their goal is a Q above 10, which is already a huge step for pure fusion.
Right.
And remember that breakthrough at the U.S. National Ignition Facility back in 2022?
Vaguely, yeah. That was a big deal, too.
It was. But they achieved a Q of about 1.5. So jumping to a target of 30, it's not just a bit better. It suggests a potential for practical, efficient power generation that's really different.
Wow, okay. That really puts it into perspective. So this isn't just a lab experiment then. They're actually aiming to put power onto the grid.
That's the plan. The stated goal is continuous electricity generation, around 100 megawatts.
And 100 megawatts is comparable to what?
It's roughly equivalent to a small conventional nuclear plant, but crucially, potentially with much higher fuel efficiency later on.
Interesting. And it's a joint project, right? Not just one state company.
Correct. It's a collaboration between the China Nuclear Industry 23 Construction Corporation, that's a state entity, and a private company, Lianovation Superconductor.
So public-private partnership, that's significant too.
It shows a coordinated effort, pooling different kinds of expertise.
And the name, Tsinghua, spark. It sounds quite deliberate. Is there a story there?
There is. Apparently, it's inspired by a famous quote from Mao Zedong, "A single spark can start a prairie fire."
Ah.
So yeah, it's a pretty potent metaphor. It suggests they see this project as having the potential to ignite something much, much bigger in the energy world.
Okay, so we get the scale of ambition, but
Yeah.
let's dig into the how. How does mixing fusion and fission actually work in this reactor? What's the trick?
This is where the hybrid concept gets really clever. Instead of just trying to sustain a pure fusion reaction indefinitely, which is incredibly hard.
Right, that's the challenge ITER is tackling.
Exactly. Tsinghua plans to use the fusion part primarily as a source of high-energy neutrons. Fusion reactions naturally produce these particles.
Yeah.
Then, these super energetic neutrons fly out and hit surrounding materials, likely fission fuel, like uranium. And those neutrons trigger fission reactions in that material.
Ah, I see. So the fusion isn't the main power source itself. It's more like the ignition system for the fission part.
In a way, yes. It's a two-stage process. The waste product of fusion, the neutrons, becomes the fuel or trigger for fission. It creates this synergistic effect.
Like using the exhaust from one engine stage to power the next.
That's a pretty good analogy, actually. And this approach could have some major advantages.
Such as?
Well, first off, energy output. Some reports, like in Sustainability Time, suggest this could potentially yield around 4 times more energy from the same amount of nuclear fuel compared to a standard fission reactor.
4 times. That's
Yeah.
a huge efficiency gain.
It really is. If that pans out, it's significant.
But I remember reading something else, too, about the nuclear waste problem. Does this hybrid approach help there?
Yes, and this could be arguably one of the most transformative aspects. It's about the fuel cycle.
How so?
The high-energy neutrons from the fusion stage are particularly good at interacting with uranium-238. Uranium-238 is the most common type of uranium, but it's not easily fissionable in standard reactors. It makes up the bulk of spent nuclear fuel, and it stays radioactive for a very, very long time. It's a big part of the long-term waste challenge.
Okay.
The idea with Xingluo is that these fusion neutrons can effectively burn this uranium-238, using it as fuel to generate more energy through fission.
So, you're saying it could potentially use existing nuclear waste as fuel.
That's the potential, yes. It could effectively transmute or fission some of those long-lived waste products, generating more power and reducing the volume and long-term hazard of the waste that needs deep geological disposal.
Wow. That would be incredible. I mean, nuclear waste has always been the Achilles heel, hasn't it?
It's been a major public concern and a technical hurdle for decades, absolutely. So the possibility of tackling that while also boosting energy production, that's why this hybrid concept is so compelling.
Okay, the potential benefits seem enormous. But let's talk timeline again. 2030 for grid connection. That just sounds incredibly soon for something this advanced.
It does. It's definitely an aggressive target.
How does it stack up against, say, ITER or other big fusion efforts globally?
Well, as we mentioned, ITER is aiming for first plasma soon, but actual electricity generation isn't expected before 2035, maybe even later. Other pure fusion concepts are also generally looking at the 2030s or 2040s for potential power plant prototypes.
So if Xingluo hits that 2030 mark.
If they manage it, China would be years ahead in demonstrating a fusion-derived energy system actually putting power onto the grid. That gives them a potentially significant competitive edge.
And the location choice, Yaohu Science Island in Nanchang. Is there anything strategic about that specific place? You mentioned copper earlier?
Yes, that seems quite intentional. Nanchang is in Jiangxi province, which is known for its copper resources.
And copper is needed for?
Superconducting magnets. These advanced reactors rely on incredibly powerful magnets to contain the superheated plasma, and those magnets need superconducting wires, which often use a lot of copper.
So locating the facility near the raw materials makes sense. It suggests joined-up thinking.
It points towards a well-integrated national strategy, aligning resource availability with technological development goals.
Which brings us to the bigger picture. How does Xingluo fit into China's overall energy strategy? What are they trying to achieve?
Well, it fits very neatly into several key goals. China is actively trying to reduce its heavy reliance on coal. They expect their coal consumption to peak around 2025, actually quite soon.
So they need alternatives fast.
Exactly. They have massive targets for renewable solar and wind. The projection is something like 1,720 gigawatts combined by 2030. That's huge.
Wow.
But they're also significantly expanding their conventional nuclear power capacity. And overarching all of this is their commitment to reaching carbon neutrality by 2060.
So Xingluo is like a high-tech bet within that broader decarbonization push.
Yep.
A potential way to get clean, reliable baseload power.
Precisely. It represents a potentially faster route to harness fusion's benefits, even if indirectly via fission, helping meet those huge energy demands while also hitting climate targets and ensuring energy security.
And if they pull it off first, becoming the leader in commercial fusion-derived energy. What does that do to global energy politics competition?
Oh, it could significantly shift the dynamics. Being first to market with a potentially game-changing energy technology like this brings enormous economic and geopolitical advantages.
You'd expect other countries to react, right? To step up their own programs.
Absolutely. It could spur a new wave of investment and competition in fusion and advanced nuclear research globally. We're already seeing China consolidating its efforts, too.
How so?
They established something called China Fusion Energy last year. It's a big consortium, 25 state-owned companies, universities, research institutes, even private firms, all led by the China National Nuclear Corporation, CNNC.
So a really coordinated national push.
Yeah, it signals a very high level of national commitment and resource mobilization behind achieving leadership in this field.
Okay, but with any nuclear project, especially something novel like this, there are always environmental questions, safety concerns. What are they doing on that front?
That's a crucial point. The sources we looked at, like Sustainability Times, do mention that a comprehensive environmental impact assessment, or EIA, is currently underway for Xinguo.
What does that involve?
It typically looks at a whole range of potential impacts on air quality, water, noise levels, local ecology, that sort of thing.
And safety. Risk.
Yes, the reporting indicates the assessment also includes developing risk management plans and setting up long-term environmental monitoring programs.
So they are going through the standard regulatory hoops, at least publicly.
It appears so.
What do I?
Publicly announcing the EIA process suggests they understand the need to address environmental concerns and build public confidence, especially for a first-of-its-kind facility. Balancing innovation with safety and sustainability is key.
Right. It's essential for public acceptance, isn't it?
Absolutely,
Yeah.
especially with nuclear technologies.
Okay, so let's try and pull this all together. As we wrap up this deep dive, what are the main things our listeners should really take away about China's Xinguo reactor?
I think there are maybe 3 core takeaways for people to keep in mind.
Okay.
First, this Xinguo project is genuinely innovative. Its fusion-fission hybrid approach isn't just tweaking existing tech, it's trying something fundamentally new that promises much higher efficiency.
And the waste reduction potential.
And, critically, that potential to actually reduce the problem of long-lived nuclear waste. That's huge.
Okay, that's point one. What's second?
Second is the timeline and ambition. Aiming for grid connection by 2030 is incredibly fast. If achieved, it could really put China in the driver's seat for this next generation of nuclear energy.
A potential leader in the field.
Potentially, yes.
No.
And third, this isn't happening in a vacuum. It's part of China's massive strategic push towards cleaner energy and carbon neutrality, and it has the potential to significantly alter global energy competition and collaboration.
It definitely feels like one of those developments we need to watch very closely, moving from sci-fi concepts to, well, potential reality.
It really does. It's fascinating to see theory potentially becoming engineering practice on this scale.
Which leaves us with that final question to mull over, doesn't it?
Indeed. How will this push from China influence what other countries do? Will it lead to more collaboration or fiercer competition in the race for clean energy?
And what other consequences, maybe ones we haven't even thought of, could emerge from this kind of technological leap?
Exactly. Plenty to think about, and certainly a story we'll be following.